Assalamu alaikum wa rahmatullahi wa barakatuh. May the peace and blessings of Almighty Allah be upon us all. Welcome our cherished viewers to another mathematics lesson. We are going to continue the test of divisibility and also do highest common factor today. So for today's topic, we are going to deal with the continuation of the test the two. Okay, so we started the last time and we did 5 rules. So today I'm going to take the last 5 rules, then we'll end the test of divisibility. Now, for rule on numbers being divided by 7, if the unit digit is doubled and subtracted from the remaining digit, the result is divisible by 7. The unit digit doubled and subtracted from remaining then the result is, that is for 7. Rule 7. For numbers being divided by 8, if the last 3 digits is divisible by 8, last 3 digits for 9, the sum of its digits is divisible by 9. That's 9, this 8. And rule 9. For 10, if the unit digit is 0, that is for 10. And for 11, the last one, if the digit alternately subtracted and added so that is the last 5 rules of test of divisibility. So they are saying that with 7, the unit digit is doubled and subtracted from the remaining results. And if the answer is being divided by 7, then 7 can divide. For 8, the last 3 digits is being divided by 8. And for 9, if the sum of its digits is divided by 9. And for 10, when the last digit is 0. And for 11, when the digits are alternately subtracted and added, and the result is being divided by 11. So let's take an example. Okay, so let's use the rule to help us solve this question. Let's say if this question has been given in exams or in an assignment. So determine whether the following 364, 95, 682, and 100 is divisible by I, 7, II, 10, and III, 9. So when we take I for 7, they said the unit digit is doubled and subtracted from the remaining. So when we take 360, the unit digit is 0. When you double 0, it's still 0. When you subtract from 36, the answer is what? 36. So this means that 0 times 0, you get 0. Then you subtract it from the remaining, that is 36 minus 0. Then you get what? 36. So when this number is being divided by 7, then it means 7 can go. When we are saying 717, we can't get 36. So this means that this number 7 can't go. When we choose the next one, which is 495, unit digit is 5. Double it. 5 times 5. The answer, 25. Then we subtract from the remaining. The remaining is what? 49. So 49 minus 25. So 9 minus 5, 4. And 4 minus 2, 24. And 7, 3, 21. 7, 4, 28. So this one too, 7 can't go. So let's take the next one. That is 682. We have 2 times 2. That is 4. Then 68 minus 4. 64. 7, 7, 49. 7, 8, 56. 7, 9, 63. So this one too can't go. And definitely 100 to 7 can't go. So we go to the next one, which is II, the 10. Said when the last digit is 0, then 10 can go. So let's check. What numbers have the last digit to be 0? 360 and what? 100. Okay. So with 360, we all know when we are saying our 10, 1, 10, with our long division, if you want to check, we have 10, 10, 3, 30. Subtract, you get 6. Then add is 0. Then 10 goes into 60. How many times? 10, 6, 60. So 36. Or 360 divided by 10. 0 cancels 0. And 36 over 1 is 36. But for the 100, 10, 10, 100. Okay, so you go to 9. You go to 9. Okay, so for 9, they said sum of 8 digits is divided by 9. So when we take 360, we get 3 plus 6 plus 0. Then we get 9. Okay, and 9 divided by 9 is what? 1. So this is correct. So then we take the next one. 495. So 4 plus 9 plus 5. 13.
13 plus 5, 18. 9 to 18. So this one too is correct. Then you take 100. No, 682. 682. 6 plus 8 plus 2. 6 plus 2. 6 plus 8, 14 plus 2. 16. 16. Can't go. 9 can't go, so it's wrong. And 100 definitely too. 9 cannot go. Cannot divide. I guess by now you are able to get what we are trying to put across. These are something you should brainstorm it into your brain. You keep it forever. Where you can remember, it helps you to move very fast and go. When you cannot remember, then you are supposed to use your long division to get the answers. Now let's go to the next topic, which is the finding the HCF of given numbers. That is the highest common factor. So the other day I asked you what is a factor. And we said that a factor is a number that can divide another number exactly without a remainder. Example, 3 is a factor of 15 because 3 goes into 15 or can divide 15 5 times, or 3 times 5 gives us what? 15. So 3 is a factor of 15 and 5 is also a factor of 15. So now they said we should be able to produce the highest common factor when a set of numbers are given to us. When a set of numbers are given to us. So let's take an example. Find the HCF of the following. A, 20, 40, 65. B, I want us to get some figures which might help us solve these questions or this topic easily. As we said, in MTA mathematics lesson, we are making mathematics easier for the learner. We are making mathematics easier for the learner. So B, 240, 330, 339. C, 216, 180, 306. D, 36, 90, 60, 54. Okay, so we have been asked to find the highest common factor of the following numbers. So let's solve and see how it goes. We are going to make mathematics easier for the learner in the house. Let's take our normal one. We were taught this method. So when we come out with a 20, we open a curly bracket. Then we find the factors of 20. And we all say 1 is the mother of what? All factors. And 1 and the number itself. So let's say 20 here. Then can 2 go? Yes. 2 times what gives 20? 2 and what? 10. Can 3 go? No. Can 4 go? Yes. 4, 5, 20. And 5 is already there. 6 can't go, 7 can't go, then 10 is already there, and that is it. Let's take 40. 1, mother of all factors, a little bigger than 20, so let's open the curly bracket bigger. So 1 and what? 40. 2 and what? 20. Can 3 go? No. Then 4. 4 and what? 10. Can 5 go? Yes. 5, 8, 40. So 5 and what? 8. 6 go? No. 7 go? No. 8 is already there. So we take the last number, which is what? 65. 1 and what? 65. Can 2 go? No. Can 3 go?
Let's see, 3. Let's share 60 into 3. We get 20, 25 can't be shared, so 3 is out. Can 4 go? No. 5, yes.
5 and what? 5, 12, 60. 5, 13, 65. 5, 14,
70. Okay, let's go to 6. 6 can't go. 6, 11, 66. 7. 7 can't go. 7, 8, 56. 7, 9, 63. 8. 8 can't go. 9. 9 can't go. 10. 10 can't go. 15. I don't think that 15 can go. So 51, 15, 52, 30. 15, 3, 45. 15. Okay, so I think that is 65 also. So from there, then we are asked to find the what? Common factors. Which factors are common to both sides? We have 1 here, 1 is here. So 1. 2 is not common to all. 5 is common. 1, 2, 3. So 5 is also common. Then, looking at this, there is no number which is common again. So that is it. So from the common factors, that is CF, common factors, you find what? You choose the what? Highest. So you just write therefore your HCF is what? 5. Okay. I'm going to teach you another method, which is far, far easier than this, which will help you move faster using the table and the prime numbers. That's what we are going to do. And most of the time, this one also helps us when the numbers are huge. Because somebody say, I mean, I don't like prime numbers, so I will not do it. But you realize that when you learn it very well and you are conversant with it, it helps you when you get huge figures. Now let's see. We have 20. We have 40. We have 65. Now, this is what we do. We are going to use prime numbers to break these numbers down. When the number is able to divide all 3 numbers, don't underline that prime number. But if not, underline it. So our first prime number, can it go into any of the numbers there? Yes, 2. 2 goes into this, 10. Goes into 40, 20. Can it go into 65? No. So we underline the 2. Then repeat the number which it can't go. Repeat it. 2 can do the job again. Yes, 2 goes here, 5. 2 goes here, 10. Can't go into this, so I repeat. So I'll still underline my 2. I bring another 2 again because of the 10. So can't go into this. I repeat it. It goes into this, 2, 5, 10. Can't go, I repeat. So since it also didn't go into all the 3, I underline. Okay, now which next prime number? 3. 3 can't go. So we go to the next prime number, which is what? 5. 5 goes here, 1. 5 goes here, 1. Can 5 go into 65? Yes, 13 times. Since it went into all, I wouldn't underline the 5. And 13 itself is also a prime number. When we bring 13 here, 30 can't go into 1, so I repeat. Can't go, I repeat. Goes here 1. So since it didn't go into all, that one to underline. So at the end of the day, the number you didn't underline on this section of the prime numbers will be your answer. So looking here, you could see that it is only 5 which hasn't been underlined. So you just come down and write therefore HCF is equal to 5. So you could see the student using this method and the one also using this method gets the same answer. I guess I'm okay. Now let's see why I'm saying the table method is very friendly when it comes to huge numbers. Only if time will permit us to do all. As for C and D, it will be your assignment. Now, let's take B. Look at 240. We are going to look for the factors of 240. So we have 1.
Let's bring it here. Let's say 240. Can 2 do the job? Yes, 2. 2 goes here, 120. Can 3 do?
3 goes to 24, 3, 8, 24, 3, 9, 27.
Okay, so meaning 3 can also go 3 and 80. Can 4 go? 4, 1, 4, 4, 2, 8, 4, 3, 12, 4, 4, 64, 5, 24, 6, 24. So 4 so can go into it 60 times. Can 5 go? Because of the 0, 5 also can go. 5 goes here, 5. Okay. So 5 can also, 5, 5, 25. So I go back 1. 5, 4, 20. So 5, then 4, 5, 4, 20. Then I get 40. So 5, 8, 40. So 48. 6. Then we said 6, 4, 24. So 6 and 40. 7, 7, 3, 21, 7, 4, 28. No. Then we go to 8. 8, 1, 8, 8, 2, 16, 8, 3, 24. So 8 and 30.
So you could see we'll be going on and on. So let's try and use our table method and see how it works.
So we could see students struggling here. So let's see our table method. We have 240, we have 330, we have 339. 2 goes here, 120. 2 will go into this, 150. 150, give me 300. I share 30 into 2. I get 15. 165. 2 can go, I repeat. The same 2 can go into this 60. Can't go, I repeat. Can't go, I repeat. 2. Since it didn't go into all, you need to underline. 30. I repeat. I repeat. 15. I repeat. I repeat. 3. 3, 5, 15. Can 3 go into this? 3, 5, 15. 3, 5, 15. 1. 55. So 55. 3 goes into this 1, goes into this 1, goes into this 3.
Okay, so since 3 went into all, I will not underline it.
So when I get here also, 3 cannot go the job again. So I come to what? 5. 5 goes here 1, 5 goes here 11. 5 can't go into this. So I underline. Then the next prime number is 11 itself. 1, 1, it can't go, I repeat. Then 1, 1, 3, 1, 1, 1, I underline.
So looking at this, you can see that only 3 wasn't what? Underlined. So therefore, my highest common factor is equal to what? 3. So you see, the student using the table method has been able to finish and has gotten the answer, whilst the student who is using this method is still on. When we started, we've even not finished this one before we even go to 330. So you could see why the table method will be easier for us when we are able to understand or understood it very well. What we are saying is that with the table method, prime numbers are used to break down the numbers given till we get 1, 1. When the number is able to divide all 3 numbers, don't underline. But if not, it goes into 2 and does not go into even 1, underline it. Where the number can't divide that number, repeat the number, like this one. 2 went into 20, 10, went into 40, 20 times, but can't divide 65, so I repeated the 65. So that is the rule. Where it can divide, repeat the number. Where it can divide all 3 numbers or all numbers given, underline that prime number. So at the end of the day, when a number is not underlined, then it means that number is your highest common factor. That is all. But it could be that some of the exams or some of the questions also, you can solve or you get 1 and all has been underlined. And what happens? What will be the answer? The answer is 1, because we said 1 is the mother of what? All factors. But you could see that 1 is not a prime number, so it wouldn't appear here. So where you solve a question and all the prime numbers has been underlined, you just write, therefore, HCF is what? 1. Viewers, our time is fast spent. I hope this lesson has also helped us very well, especially the table method. I know by now, students are still on this old method, which is going to, at the end of the day, arrive at the answer, which is what? 3. Please understand this method, and when you understand this method very well, it's going to help you to go a long way. Thank you very much for learning with us under this episode of MTA Mathematics, where mathematics is made easier for the learner. Assalamu alaikum wa rahmatullahi wa barakatuh.